All right, so this is Geometry A Unit 6. Hold on. Unit 7, Lesson 5, Coordinate Proofs. This is a very broad topic, and it would be impossible for me to create a succinct video that covers all of it. But I hope to cover a number of pieces of it. We can prove that lines are parallel by showing they have the same slope. We can prove that lines are perpendicular by showing their slopes are negative reciprocals of each other. We can prove that lines have the same length or are congruent by using the distance formula. We can prove that two lines share the same midpoint by using the midpoint formula. So all these formulas find their use in coordinate proofs. Let me list those formulas again. So slope is rise over run, or change in y over change in x, or y2 minus y1 over x2 minus x1. That's slope. Midpoint is found by adding the x's, x1 plus x2 divided by 2, and dividing by 2, and adding the y's, y1 plus y2 divided by 2. It's an average of the coordinates. And the distance can be found by the Pythagorean theorem. The horizontal change, or change in y, which is y2 minus y1. I'm going to give it that way, actually. So change in y squared plus change in x squared. Actually, let's do change in x squared plus change in y squared. Okay, or the width and the height. Okay, and you can simplify or complicatify that a little bit by saying x2 minus x1 squared plus y2 minus y1 squared square root. Okay, so those are the formulas that we need to know. And those formulas tell me a lot. The slope formula tells me whether two lines are perpendicular or parallel. The midpoint formula tells me if a point is on the midpoint, or if two segments bisect each other or share the same midpoint. And the distance formula is used to tell me if two segments are congruent. So let's use that in this particular case. A is 2, 4, 2, 4, 5. So A is negative 5, negative 2. B is negative 1, 2, 4, 5. C is 2, 4, 6, 7, 7, 4. And D is 3, negative 3. 3, negative 3. Okay. My 3's come out looking like my 5's sometimes. Okay, and I want to prove as much as I can here about this, and so I'm going to go rather quickly. So the first thing I'm going to do is I'm going to find the slopes. The slope of AB is rise over run, and you can do it this way: 2, 4, 6, 7, 2, 4. So the slope of 7 is change in y, up 6, 2, 4, 6, 7, up 7, and over 2, 4. The slope of BC, actually let's go AD, which spells mad. Slope of AD is rise over run. So rise, actually not AB, I want CD. CD. Slope of CD is rise 2, 4, 2, 4, 6, 7 over 4. So I can conclude from this that AB is parallel to CD. Okay. Likewise, I can find the slope of BC. Slope of BC is down 1 and over 2, 4, 6, 8. Down 1 over 8. The slope of AD, which spells mad, is down 1 and over 2, 4, 6, 8. So negative 1/8. Since the slopes are the same, BC is parallel to AD. Segment BC is parallel. So we've proven that those two segments are parallel. And now the combination of both of these facts, the fact that BC is parallel to AD, and the fact that AB is parallel to DC, tells me this is, and this serves as a proof that this is a parallelogram. Okay? Let's use the distance formula. Distance formula. AB is change in y, 2, 4, 6, 7 squared, plus change in x, 4 squared. 7 squared is 49, 4 squared is 16, 49 and 16 is 55. Doesn't simplify since that's just 5 times 11. Okay, so the distance between A and B is root 55. The distance between B and C is down 1, so 1 squared, over 2, 4, 6, 8. Now, say 2, 4, 6, 8. Yeah. Hold on. 7 squared, 2, 4, 6, 7, 2, 4. Okay, 7 squared, and it's 49. 50, not 55, 65. 65. Maybe there was an arithmetic error that was creeping in and was bugging me. Those will get you. Those will get you for sure. 65, root 65. 1 squared plus 8 squared is 1 plus 64 equals root 65. So this is root 65. So I can conclude that AB is congruent. Segment AB is congruent to segment BC. Right? So these segments are congruent. CD. Rise over run, or change in y squared plus change in x squared. So CD. So 2, 4, 6, 7, and 2, 4. So 4 squared plus 7 squared. We've seen that before. Root 16 plus 49 is root 65. And then DA, or AD, is 1 and 8, or 1 squared plus 8 squared square root is 1 plus 64 square root is root 65. So all of this tells me that all 4 of these are congruent. AB is congruent to BC, is congruent to CD, is congruent to AD. And since all 4 sides are congruent, the combination of these things tells me that ABCD is a rhombus. A rhombus is a quadrilateral with all 4 sides congruent. Okay? So that falls out of this. The distance formula tells me if segments are congruent. Okay, let's change colors again and let's deal with diagonals. So I'm going to, dia meaning through, diagonals, through the angles basically is what it means. Diagon, gons are angles in Greek. Lots of Greek in math terms. Dia meaning through, gonal meaning angle, through the angle. Okay, so let's find the slope of AC, the MAC. Slope of AC is rise over run, right? So 2, 4, 6, 2, 4, 6, 8, 10, 12. 6 over 12, which is 1/2. And the slope of VD. Umbada. Rise over run. So 2, 4, 6, 8, 2, 4. 8, 4, but it's going down, so it's negative. I'm going to put it negative 2 over 1. These are negative reciprocals of each other. 1/2 flipped over is 2 over 1, and one's negative, one's positive. Therefore, AC is perpendicular to VD. So we know this forms a right angle. These are perpendicular. One more thing I want to add here. Let's go orange here. Orange. Nothing rhymes with orange. Okay. So the midpoint of AC, the average of the x's, the average of the y's. So negative 5 plus 7 divided by 2, and negative 2 plus 4 divided by 2. Negative 5 plus 7 is positive 2 divided by 2. And negative 2 plus 4 is 2 divided by 2, which is 1, 1. So the midpoint of AC is 1, 1, and that's what we see on the graph. 1, 1. Okay, the midpoint of VD is average of the x's, average of the y's. So negative 1 plus 3 divided by 2, comma, and 5 minus 3 divided by 2, which is 2 divided by 2 and 2 divided by 2, which is 1, 1. So it's the same. They both share the same midpoint. So we've just proven that AC and VD bisect each other. And if we combine that with the fact that they're perpendicular, then they're perpendicular bisectors. Okay, so we've just proven a lot of stuff about this shape. We've proven it's a parallelogram because opposite sides are parallel. We've proven it's a rhombus because all the sides are congruent. We've proven that the diagonals are perpendicular, and we've proven that the diagonals share a common midpoint and bisect each other.